3.8 Application of Integration to find area. For the introduction, integration is a powerful mathematical tool that can be used to find the area under curve and base curve. This technique is known as the defined integration, and it involves making the integral of a function over a specific interval. Finding the area between a curve and the axis. Suppose you have a curve defined by the function fx, and you want to find the area between this curve and the axis within a specific interval a and b. You can use integration to calculate this area by elevating the defined integral.
Good afternoon. My name is Muhammad Narish Isaac bin Muhammad Najib. Number metric is 1043, and today I'm going to do some question about how to find area using integer. So as you can see at this question, we use the equation y equal to x squared plus x plus 4, and then the upper limited is 3 and the lower limited is 1. So we use the formula integrate upper limited 3 and lower limited 1 y dx. First we integrate the equation first, and then it will become bracket x power of 3 over 3 plus x squared over 2 plus 4x upper bracket 3 and lower bracket 1. So we enter the value, and then it will become 27 over 3 plus 9 over 2 and plus 12 in brackets minus in bracket also 1 over 3 plus 1 over 2 plus 4, and then we will get 25 over 1 over 2 minus 4 over 5 over 6, and then which equals to 20 over 2 over 3 units of area. So that's all for me. I will proceed to our next member.
Application of integration to find value. If a region in the plane is relevant about a given line, the resulting solid is a solid of revolution, and the line is called the axis of revolution. When calculating the volume of a solid generated by revolving a region bounded by a given function about an axis, follow the step below. First, sketch the area and determine the axis of revolution. This determines the variable of integration. 2. Sketch the first section. This shell washer, and determine the operation of formula. 3. Determine the boundaries of the solid. 4. Set up the defined integral and integrate. The simplest solid of revolution is a right of circular cylinder which is formed by revolving a rectangle about an axis adjacent to one side of the rectangle. To see how to calculate the volume of a general solid of revolution with a disc cross section using integration techniques. Consider the flowing solid of revolution formed by revolving the plane region bounded by fx y-axis and the vertical line x to about the axis. In other words, A equation and fx of fy depending of the axis of revolution. In other words, A equation and fx or fy depending of the axis of revolution. The volume of the solid generated by region under fx bounded by the x-axis and vertical lines x equation A and B, which is a revolute about the x-axis. The volume of the solid generated by region under fy to the left to fy, bounded by the y-axis and horizontal lines y equation C and y equation D, which is a revolute about the y-axis.
Okay, for the next slide, we have example solution, application of integration to find value. For the question is y equal to per x, and we have a formula volume vx equal pi integration upper 4 lower 1 y square dx, and y is question 2 per x. We input at the in for the next 2 square per x square. We have a multiplication, and answer is 4 per x per dx, and then we have 4 pi integration upper 4 and lower 1 for x power of negative 2 dx. Okay, the next step, for x lower negative 1 per negative 1 and upper 4 lower 1, we have use the formula, and the formula, the solution is 4 bracket 4 power of negative 1 per negative 1, and negative 4 bracket 1 power of negative 1 and per negative 1. To find the final answer, we calculate the bracket negative 1, negative, bracket negative 4, and the final answer is 3 pi